Hi, I'm Sai Krishna. So let us look at the question 2. In the question 2, we have said that x is uniform between a and b and y is given as x square. So in part A, we are asked to find and draw the density function and distribution function of x. So let us look at this answer for this. So question number 2, given that y is x square and x is uniform in between a and b. Okay, so we can calculate the density function of x as 1 by b minus a, given that x is between a and b. For x greater than b, it is 0. Okay, so let us draw the graph for this as well. We can clearly see that as the boundaries are included, this turns out to be a graph of this format, the density function. So let us look at the distribution function of x. For the distribution function of x, we know that distribution function of x is the integral between minus infinity to infinity density function of x dx. So here it is integral a to x dt by b minus a, because given that b minus a is the density function, we have calculating the distribution function. So it is x minus a by b minus a. So we can see that the distribution function of x is 0 when a is greater than x. Okay, in this case it is 0. Between a and b, it is x minus a by b minus a, the thing that we have just calculated. So it's a less than or equal to x less than b, and for x greater than b, it is 1. So let us draw the graph here itself for this. So for this, the graph is between a and b. It is from a greater than x, it's this thing 0, given that it's x minus a by b minus a, so it increases like this, it becomes constant. So here we know that it's x minus a by b minus a. This is the distribution function of x given x. So this is the graph. This is the graph for density function and distribution function. So we have completed the part A. So let us look at the part B for this question. In the part B for this question, we are asked to calculate the density function and distribution functions of y, and also commute expected value of y given that a equal to -1 and b equal to 3. So second question, b bit. We know that the density function of x is how much? 1 by b minus a. 1 by b minus a when a is less than or equal to x is less than or equal to b, and 0 otherwise. And the distribution function of x as how much? 0 when a is greater than x, x minus a by b minus a when a is less than or equal to x is less than or equal to b, when x is greater than b, it's 1. Okay, so this is the density function and distribution functions. We are asked to calculate the we are given the value of minus a equal to -1 and b equal to 3. So let's plug in the values over here. So it becomes 1 by 4 when -1 is less than or equal to x is less than or equal to 3, 0 otherwise. So for this thing, it becomes 0 when 1 is greater than x, and minus 1, sorry, minus 1 is less than or equal to x is less than or equal to 3, this becomes x plus 1 by 3 plus 1, so it's 4. And when x is greater than 3, this becomes 1. Okay, I've just plugged in the values. Now we have to calculate the density function and distribution functions of y. Yeah, so let us first calculate the distribution function of y, because by this format it becomes easier to calculate the density function of y, as it is just the derivative of distribution function of y. So this is equal to probability that y is less than or equal to, yeah. So I've just plugged in the formula. So this becomes, we have given that y is x square, so substitute it here, less than or equal to y. So this becomes y root y is less than or equal to x is less than or equal to root y. Okay, so this is minus root y. So yeah, this is the x lies between minus root y and root y. Okay, so this can be written as fx, that is the distribution function of root y minus fx of minus root y. Okay, so let us substitute the values, and let us first find the ranges of distribution function of y, so that we can find the graph for this. We can just substitute the values here. So for 0, for we are given that a is equal to minus 1 and 3. So here we know that y is between x square. So y is between y is between 1 and 9, but there is an interval 1 and 0 and 1, because here it is x is uniform between minus 1 and 3. So there is an interval 0 and 1, so that we have to include that as well. So it's 0 and 1 as well. So for 0, when x is less than 0, so, and for between 0 and 1, 0 less than or equal to x less than or equal to 1. So between 0 and 1, we have the negative part, the minus 1 part takes precedence. So we have to include this as well. So it is just substitute the root y in this here, the f of x case, the distribution function. So this becomes root y plus 1 by 4 minus of minus root y plus 1 by 4. Okay, this turns out to be minus or minus plus, so 1 cancelled. So this becomes 2 root y by 4, which is root y by 2. Between this interval, this is root y by 2. Between 1 and 9, between 1 and 9, only the positive value takes precedence, so it's 1 by 4. Okay, and for all the other values it is the same thing, which is 9. So it's, I'm sorry, this is y. Sorry, this is y, because we're calculating the distribution function of y. So this is y. So 1 when y is greater than 9. So let us draw the graph for this. For the value y less than 0, it's 0. So here comes y, here comes the distribution function of y. So it's 0, and then 0 for 0, and then it becomes, so for 1, this becomes half, so it increases to half, and then between 1 and 9 this becomes, so it's when I substitute 9, this is 1, so it increases to 1, so this is 1, and then after 1 it is just a constant thing. So this is the graph for this. So yeah, so let us continue with the density function of y. We know that density function of y is just the derivative of distribution function of y, and we have calculated the distribution function of y. So this becomes so here we know that root y, so of root y by 2, so after we differentiate this become 1 by 4 root y. Yeah, okay, when y is between 0 and 1, and 1 by 8 root y when y is between 1 and 9. When y is greater than 9, it is 0. Okay, so let us draw the graph for this. Okay, this is y, this is the distribution function of y. Okay, so this is 0, and then when I substitute 1 here, this becomes 1 by 4. Okay, when I substitute 9 here, this becomes 1 by 9 here, this becomes 1 by 24, and then this decreases here. So this is the graph that I got for distribution function of y. Now let us calculate the expected value of y. For expected value of y, it is a simple formula, minus infinity to infinity y of fy of y. This is equal to so there's an interval between 0 and 1, and it is 1 by 4 root y, and there's a y the numerator, and then there is a y here as well, and the interval y between 1 and 9, it's 1 by 8 root y, so it's 1 by 8 root y dy. So this becomes half, this becomes cancelled, this becomes half, this becomes cancelled, and this is y to the power of half plus 1 by half plus 1 into 4, and this is the interval between 0 and 1, and this is y to the power of half plus 1 yeah, and by 8 into half plus 1. This is the interval between 1 and 9. So let us calculate this. So this turns out to be y to the power of 3 by 2 by 4 into 3 by 2 plus this is the value between 0 and 1, y to the power of 3 by 2 by 8 into 3 by 2, this is the interval between 1 and 9. 1, this is 1. So y to the power of 3 by 2 by, this is 2, so this is 6, plus y to the power of 3 by 2 by, this is 4, so this is 12, between 1 and 9, between 1 and 9. So this is equal to 9 to the power of between 0 and 1, sorry, so this is 1 to the power of 3 by 2 by 6 minus 0, so this is 0, plus 9 to the power of 3 by 2 by 12 minus 1 by 12, so this is 1, so this is 1 by 6 sorry, plus 3 square into 3 by 2 by 12 minus 1 by 12. So this is equal to 1 by 6 plus 2 get cancelled, so it's 27 by 12 minus 1 by 12. So into 2 into 2, I'm just taking LCM, 2 plus 27 minus 1 by 12. So this is equal to 28 by 12. This is equal to 7 by 3. 7 by 3. So this is 7 by 3. So I've got expected value of y as 7 by 3. So in this way I've calculated the A and B bits. Thank you.